Hi. Today I'm going to tell you 100 sleepy facts about Mars, perfect if you want to relax a bit and learn something interesting about the red planet. Enjoy listening. 1. Mars is often called the red planet. The planet got this nickname because of its reddish appearance when seen from Earth. This color comes from iron oxide, or rust, covering much of its surface. Ancient civilizations noticed Mars' unusual red glow and associated it with war and blood. Even today, its striking color makes Mars easily recognizable in the night sky. 2. Mars is the fourth planet from the Sun. It lies at an average distance of about 227.9 million kilometers, 141.6 million miles, from the Sun. This makes it colder and less hospitable than Earth, though still more Earth-like than most other planets. Its position also explains why Mars takes nearly twice as long as Earth to orbit the Sun. Day 3. A day on Mars is slightly longer than a day on Earth. One Martian day, called a sol, lasts about 24 hours and 37 minutes. This makes its daily cycle very similar to Earth's, which would help humans adapt if we colonized the planet. The small difference could even make Mars the easiest planet for humans to adjust to in terms of circadian rhythm. 4. A year on Mars is almost twice as long as a year on Earth. Mars takes 687 Earth days to complete one orbit around the Sun. This means its seasons last much longer than those on Earth. For example, winter on Mars can last for over 150 Earth days, which significantly affects its climate and surface conditions. 5. Mars has two small moons, Phobos and Deimos. Both moons are irregularly shaped and look more like asteroids than typical spherical moons. Scientists believe they might actually be captured asteroids from the nearby asteroid belt. Phobos orbits very close to Mars and is slowly spiraling inward, while Deimos orbits farther away and is more stable. 6. Mars is about half the size of Earth. Its diameter is approximately 6,779 kilometers, 4,212 miles, compared to Earth's 12,742 kilometers, 7,918 miles. Because of its smaller size, Mars has less gravity, about 38% of Earth's. This means a person weighing 100 kilograms on Earth would weigh only 38 kilograms on Mars. 7. The gravity on Mars is weaker than on Earth. Mars' lower gravity would make everyday activities feel very different. Humans could jump higher and carry heavier loads with less effort. However, the weaker gravity could also negatively affect long-term human health, particularly bone density and muscle strength. 8. Mars has the largest volcano in the solar system, Olympus Mons. Olympus Mons is about 21.9 kilometers, 13.6 miles, high, almost 3 times taller than Mount Everest. Its base is so wide that it covers an area roughly the size of the U.S. state of Arizona. Scientists believe it is a shield volcano, built up by repeated lava flows over millions of years. 9. Mars also has the largest canyon in the solar system, Valles Marineris. This massive canyon system stretches over 4,000 kilometers, 2,500 miles, long and up to 7 kilometers, 3 miles, deep. It dwarfs the Grand Canyon in the United States, which is only about 446 kilometers, 277 miles, long. Valles Marineris likely formed from tectonic activity, crust stretching, and erosion. 10. Mars has polar ice caps. At both poles, Mars has large ice caps made of water ice and frozen carbon dioxide, dry ice. These ice caps grow in winter and shrink in summer as temperatures change. The presence of water ice is especially significant for future human colonization and possible evidence of past life. 11. Mars has a very thin atmosphere. The atmosphere is about 100 times thinner than Earth's and is mostly made of carbon dioxide, 95%, with small amounts of nitrogen and argon. This thin atmosphere cannot trap much heat, making Mars very cold. It also means there is almost no protection from harmful solar radiation. 12. The average temperature on Mars is extremely cold. The average surface temperature is around -63 degrees Celsius -81 degrees Fahrenheit, though it can vary widely. In summer near the equator, it can reach up to 20 degrees Celsius 68 degrees Fahrenheit, but at night it may drop to -73 degrees Celsius -100 degrees Fahrenheit. This extreme variation makes survival without special equipment impossible. 13. Dust storms are common and powerful on Mars. Mars experiences planet-wide dust storms that can last for weeks or even months. These storms can cover the entire planet and block sunlight from reaching the surface. Such events are a major challenge for solar-powered rovers and future human missions. 14. Mars once had liquid water on its surface. There is strong evidence that rivers, lakes, and even oceans once existed on Mars. Dry riverbeds, minerals that form in water, and layered rock formations all suggest a watery past. This makes Mars one of the most promising places to search for signs of past life. 15. Mars still has water today, mostly as ice. Although liquid water cannot exist on the surface for long due to low pressure, there are large deposits of frozen water beneath the surface. In some areas, salty liquid water may exist underground. These hidden reservoirs could provide resources for future human settlers. 16. Mars has seasons, just like Earth. Because Mars is tilted on its axis by about 25 degrees, similar to Earth's 23.5 degrees, it experiences spring, summer, fall, and winter. However, since Mars takes longer to orbit the Sun, its seasons last roughly twice as long as Earth's. Seasonal changes affect the polar ice caps and the appearance of the landscape. 17. The Martian atmosphere creates stunning sunsets. Unlike Earth's red and orange sunsets, sunsets on Mars appear blue. This happens because of the way fine dust particles scatter sunlight in the thin atmosphere. The result is an otherworldly twilight that is completely different from anything seen on Earth. 18. Mars has been explored by many robotic missions. NASA and other space agencies have sent orbiters, landers, and rovers to study Mars. Notable rovers include Spirit, Opportunity, Curiosity, and Perseverance. Each mission has provided valuable data about the planet's geology, atmosphere, and potential for life. 19. The first spacecraft to land on Mars was Viking 1 in 1976. NASA's Viking program consisted of 2 orbiters and 2 landers. Viking 1 was the first successful lander to transmit images from the Martian surface. These missions provided groundbreaking data on the planet's soil, atmosphere, and weather. 20. Mars is one of the most studied planets after Earth. Because of its similarities and differences, Mars offers key insights into planetary evolution. Scientists hope that by studying Mars, we can better understand Earth's past and future. Its potential for past or present life makes it especially important for ongoing exploration. 21. Mars has the tallest known mountain in the solar system. Olympus Mons rises about 21.9 kilometers, 13.6 miles, above the surface, making it nearly 3 times taller than Mount Everest. Its base is so large that it could cover the entire country of France. Scientists believe the lack of plate tectonics on Mars allowed the volcano to grow this large since the crust never moved away from the hotspot supplying the lava. 22. The Martian crust is thicker than Earth's. On average, the crust of Mars is about 50 kilometers thick, compared to Earth's 30 kilometers. This thicker crust affects tectonic activity and volcanic formation. It may also explain why Mars does not have active plate tectonics like Earth, which in turn shaped its geological history differently. 23. Mars has massive canyons formed by tectonics. The most famous is Valles Marineris, stretching over 4,000 kilometers. It likely formed when the planet's crust stretched and cracked, creating deep rifts. Later, erosion and possible water flows helped enlarge the canyon system, leaving behind one of the most dramatic landscapes in the solar system. 24. Mars' surface is covered in iron oxide dust. This iron-rich dust gives the planet its famous red color. The dust is extremely fine and can be carried by winds, sometimes forming massive dust storms. This dust also poses challenges for spacecraft equipment and could be dangerous for future human settlers. 25. Mars has weaker magnetic protection than Earth. Billions of years ago, Mars had a global magnetic field, but it collapsed for reasons still under study. Today, only localized magnetic fields remain in some regions of the crust. Without a strong magnetic shield, Mars' atmosphere has been stripped away by solar winds over time. 26. Mars' atmosphere is mostly carbon dioxide. About 95% of the atmosphere is CO2, with nitrogen and argon making up most of the rest. Oxygen is present only in trace amounts, less than 0.2%. This makes the atmosphere unbreathable for humans without life support systems. 27. Mars has extremely low air pressure. The average surface pressure is only about 0.0 6% of Earth's at sea level. This is so low that liquid water cannot remain stable on the surface, it would boil away almost instantly. For astronauts, this means pressurized suits and habitats would be essential. 28. Mars is colder than Earth. Its greater distance from the Sun and thin atmosphere mean it cannot retain much heat. Average temperatures hover around -63 degrees Celsius -81 degrees Fahrenheit, though they vary greatly between day and night. Even in warm areas near the equator, nights can be brutally cold. 29. Mars polar caps are made of dry ice and water ice. During winter, carbon dioxide from the atmosphere freezes onto the poles, creating seasonal dry ice layers. In summer, much of this sublimates back into the atmosphere. Beneath these layers lies water ice, which could serve as a crucial resource for future missions. 30. Mars has been hit by many asteroids and comets. Its surface is covered with craters of all sizes, some billions of years old. Unlike Earth, which erases many craters through weathering and tectonics, Mars preserves them due to its thin atmosphere and lack of plate movement. This makes it a natural record of the solar system's violent history. 31. Mars has no liquid oceans today. Scientists believe that billions of years ago, Mars may have had large oceans. Evidence comes from ancient shorelines and valley networks visible from orbit. However, today the planet is too cold and its atmosphere too thin to support large bodies of liquid water. 32. Mars quakes have been detected. NASA's InSight lander recorded seismic activity on Mars, proving that the planet is not completely geologically dead. These Marsquakes suggest that the crust is still shifting and cooling. Studying them helps scientists learn about the planet's interior structure. 33. Mars has giant dust devils. These whirlwinds can grow several kilometers tall and leave dark streaks on the surface. They are powered by the sun heating the ground and creating rising columns of warm air. Although not as destructive as Earth's tornadoes, they can affect landers and rovers. 34. The thin atmosphere allows more radiation to reach the surface. Unlike Earth, which has both a thick atmosphere and a magnetic field to shield life, Mars is exposed to high levels of cosmic and solar radiation. This is one of the biggest obstacles for human colonization. Long-term exposure would require protective habitats or underground shelters. 35. Mars' color changes slightly depending on dust levels. At times, it appears more orange, while during dust storms, it can look brownish or even yellow. These shifts are caused by the fine particles suspended in the atmosphere. Observers from Earth can notice these variations during different Martian seasons. 36. Some Martian rocks are meteorites found on Earth. Over the centuries, asteroid impacts on Mars have ejected rocks into space. Some of these eventually landed on Earth and were identified as Martian due to their chemical composition. These meteorites give scientists direct samples of Mars without needing to bring them back by spacecraft. 37. Mars has large volcanoes besides Olympus Mons. Other major volcanic regions include Tharsis and Elysium. These areas contain giant shield volcanoes that dwarf those on Earth. Although they are inactive today, their size shows that Mars was once highly volcanically active. 38. Mars' sky appears butterscotch-colored during the day. This unusual tint comes from sunlight scattering through dust-filled air. At sunset, however, the sky can turn blue because of the way dust particles bend light. These unique skies make Mars look both alien and strangely beautiful. 39. Mars' seasons are uneven in length. Because Mars has a more elliptical orbit than Earth, its distance from the Sun changes more dramatically. This causes one hemisphere to have longer, milder seasons while the other experiences shorter, harsher ones. For example, southern summers are hotter but shorter than northern summers. 40. The surface of Mars contains perchlorates. These are toxic chemical compounds discovered in the soil by NASA's Phoenix lander. While harmful to humans, they could potentially be used in rocket fuel production or as a resource for chemistry experiments. Their presence complicates the possibility of agriculture on Mars. 41. Mars is home to enormous impact basins. One of the largest is the Hellas Planitia, a vast impact crater over 2,300 kilometers, 1,400 miles, in diameter. It is more than 7 kilometers, 3 miles, deep, making it one of the deepest depressions on the planet. Scientists believe it was formed billions of years ago when a massive asteroid collided with Mars, reshaping its southern hemisphere. 42. The northern and southern hemispheres of Mars are very different. The northern hemisphere is relatively smooth and lower in elevation, while the southern hemisphere is heavily cratered and much higher. This sharp contrast is called the Martian dichotomy. The cause of this difference is still debated, with theories including giant impacts or early tectonic activity. 43. Mars has many dry river valleys. These valleys, called outflow channels, suggest that liquid water once flowed across the surface. Some of them are hundreds of kilometers long and appear to have been carved rapidly by catastrophic floods. They provide crucial evidence that Mars once had a much wetter climate. 44. Mars' surface has signs of ancient lakes. NASA's Curiosity rover discovered sedimentary rocks that resemble lakebeds on Earth. These rocks contain layers that likely formed in standing water billions of years ago. Such discoveries fuel the possibility that microbial life may have existed in Mars' past. 45. Mars has recurring slope lineae, RSL. These are dark streaks that appear on steep slopes during warmer seasons and fade when it gets colder. Scientists once thought they were caused by flowing salty water, but recent studies suggest they may be caused by dry landslides. The debate continues about their true nature. 46. Mars has evidence of glaciers. Beneath layers of dust, scientists have detected deposits of water ice in mid-latitudes. These hidden glaciers suggest that Mars has gone through major climate shifts over its history. They may also serve as valuable water resources for future explorers. 47. Mars' atmosphere produces thin clouds. Unlike Earth's thick, water-rich clouds, Martian clouds are often made of carbon dioxide ice or fine water ice crystals. They are usually wispy and form high in the atmosphere. Some even resemble cirrus clouds seen on Earth. 48. Mars has been observed from Earth for thousands of years. Ancient civilizations, including the Babylonians, Egyptians, and Greeks, tracked the planet's movements. Because of its unusual reddish glow, Mars was often linked with gods of war. Its predictable but strange path in the sky inspired early astronomy. 49. Mars was the focus of early science fiction. Writers like H. G. Wells and Edgar Rice Burroughs imagined advanced civilizations on the Red Planet. These stories helped spark public interest in space exploration during the 19th and 20th centuries. Even today, Mars remains a popular subject in books, movies, and TV. 50. Mars' thin atmosphere makes parachutes less effective. When spacecraft land on Mars, they cannot rely on parachutes alone to slow down because the air is too thin. Engineers use a combination of heat shields, parachutes, retrorockets, and sometimes even sky cranes. The challenge of landing is one of the hardest parts of Mars exploration. 51. Mars has giant volcanoes because of its weak gravity. On Earth, volcanoes are limited in size by plate tectonics and stronger gravity. On Mars, weaker gravity and a stationary crust allowed lava to build up over millions of years. This explains why Olympus Mons and other Martian volcanoes became so massive. 52. Mars' reddish soil could be used for construction. Future colonists might use local Martian regolith to make bricks. Experiments on Earth show that by compressing or heating the soil, strong building materials can be created. This would reduce the need to transport supplies from Earth. 53. Mars has temperature extremes between day and night. Because the thin atmosphere cannot hold heat, temperatures swing dramatically within hours. A single day might go from above freezing to well below -70 degrees Celsius -94 degrees Fahrenheit. These fluctuations pose serious challenges for future human habitats. 54. Mars' sky can sometimes glow at night. This phenomenon, called night glow, happens when molecules in the upper atmosphere release energy absorbed during the day. It produces faint but widespread illumination. Scientists study this glow to learn about the dynamics of the Martian atmosphere. 55. Mars may have once had a thicker atmosphere. Evidence suggests that billions of years ago, Mars had a denser atmosphere that could support liquid water. Over time, much of it was stripped away by solar wind after the planet lost its magnetic field. This transformation turned Mars into the cold desert world we see today. 56. Mars' gravity affects how dust settles. Because it is weaker than Earth's gravity, fine particles remain suspended in the air longer. This explains why dust storms can last so long and spread so widely across the planet. It also means dust will be a constant problem for human exploration. 57. Some Martian rocks contain evidence of organic molecules. NASA's Curiosity rover detected organic carbon in drilled rock samples. While these molecules are not proof of life, they are building blocks that could support it. Their presence keeps alive the hope that Mars once hosted microbes. 58. Mars seasons affect atmospheric pressure. In winter, carbon dioxide at the poles freezes and lowers global atmospheric pressure. In summer, it sublimates back into the air, raising pressure again. This seasonal breathing cycle of Mars is unique among planets. 59. Mars is targeted for future human colonization. NASA, SpaceX, and other organizations plan to send humans there in the coming decades. Mars is considered the best candidate for colonization because of its similarity to Earth in day length, seasons, and available resources. However, many technical and biological challenges remain. 60. Mars could teach us about Earth's future. Scientists believe Mars was once warm and wet before becoming the dry desert it is today. By studying its climate history, researchers hope to understand long-term planetary changes. This knowledge may help predict Earth's future under climate change. 61. Mars' surface is shaped by wind erosion. Because water erosion is rare today, wind is the dominant force shaping the Martian landscape. Strong winds move dust and sand, creating dunes and ripples across vast areas. Some of these dunes shift with the seasons, showing that the surface is still active. This ongoing activity gives scientists clues about present-day climate conditions on Mars. 62. Mars has giant dust storms that can engulf the entire planet. These storms are the largest in the solar system and sometimes last for months. They block sunlight, lower temperatures, and coat everything in fine dust. Such storms once ended NASA's Opportunity rover mission by covering its solar panels. Understanding them is essential for planning future human settlements. 63. Mars has layered rocks that record its history. Sedimentary rocks on Mars preserve evidence of past water flows, lakes, and even volcanic eruptions. Just like Earth's geological layers, they act as time capsules. By studying them, scientists can reconstruct Mars' climate over billions of years. This helps determine when the planet was most habitable. 64. Mars' reddish dust may affect human health. The fine dust contains toxic chemicals like perchlorates, which can damage human thyroid glands if inhaled or ingested. It also clings to surfaces, making it difficult to keep habitats and equipment clean. Future colonists will need advanced filtration systems to deal with the problem. 65. Mars has auroras, but they are different from Earth's. On Earth, auroras occur near the poles because of our magnetic field. On Mars, they can appear almost anywhere since the planet only has localized magnetic fields. These auroras are caused by solar wind particles colliding with the atmosphere, producing faint glows in ultraviolet light. 66. Mars' thin atmosphere allows meteors to reach the surface more easily. Unlike Earth, where most meteors burn up in the atmosphere, many hit the Martian ground intact. As a result, fresh craters form more frequently. NASA's InSight lander even detected seismic waves caused by meteor impacts, helping scientists study Mars' interior. 67. Mars' rotation axis tilts over time. The tilt, or obliquity, of Mars changes dramatically compared to Earth's relatively stable tilt. Sometimes it leans much more, causing extreme climate changes. These shifts may explain the presence of glaciers in unusual places. Studying this tilt helps scientists understand the planet's climate cycles. 68. Mars has valleys carved by lava. Not all Martian valleys were formed by water. Some were created by lava flowing across the surface during volcanic eruptions. These lava channels provide evidence of Mars' volcanic past and show that the planet was once very geologically active. 69. Mars has the Tharsis volcanic plateau. This massive region contains some of the largest volcanoes in the solar system. The sheer size of Tharsis may have reshaped the entire planet, influencing its crust and even its climate. The plateau is thought to have uplifted large areas and triggered the formation of Valles Marineris. 70. Mars has evidence of ancient tsunamis. Scientists have found deposits along suspected shorelines that resemble those left by giant waves. These suggest that large bodies of water, possibly oceans, once existed and were disturbed by asteroid impacts. If true, it adds weight to the theory that Mars once had a vast northern ocean. 71. Mars' thin air makes sounds different from Earth. Experiments by NASA's Perseverance rover recorded Martian sounds for the first time. Because of the low pressure, sounds travel slower and are fainter. This means a human would hear muffled and delayed noises compared to Earth. Even a clap or voice would sound strange. 72. Mars has recurring frost patterns. At night and in winter, frost forms on the surface, made of carbon dioxide or water ice. In the morning, the frost quickly sublimates into gas as the sun rises. These cycles affect soil chemistry and might influence potential habitats for microbes. 73. Mars has massive shield volcanoes. Unlike explosive volcanoes on Earth, Martian volcanoes are shield-shaped, built by repeated lava flows. Their gentle slopes spread across hundreds of kilometers. Olympus Mons is the most famous, but others like Arsia Mons and Ischrius Mons are nearly as impressive. 74. Mars moons may break apart in the future. Phobos, the larger moon, is slowly spiraling toward Mars. In about 30 to 50 million years, it may break apart under tidal forces. This could create a temporary ring system around the planet. Deimos, however, is slowly moving away and will not face the same fate. 75. Mars has dunes that sing. Certain sand dunes on Mars produce low-frequency sounds when sand slides down their slopes. Similar to singing dunes on Earth, the vibrations create a natural hum. Scientists study these sounds to learn more about the composition and behavior of Martian sand. 76. Mars has extreme elevation differences. The highest point, Olympus Mons, is over 21 kilometers high, while the lowest point, Hellas Basin, is more than 7 kilometers deep. This makes for a difference of nearly 30 kilometers, 18 miles, the largest on any planet. Such contrasts influence wind patterns and climate on Mars. 77. Mars has been mapped in high detail. Orbiters like Mars Reconnaissance Orbiter, MSRO, have produced images so sharp that individual rocks can be seen from space. These maps allow scientists to plan rover routes and identify potential landing sites. They also reveal fascinating features like collapsed lava tubes and ancient deltas. 78. Mars may have subsurface brines. Radar studies suggest that salty liquid water could exist beneath the ice at the South Pole. Brines remain liquid at much lower temperatures than pure water. If confirmed, these hidden reservoirs could be potential habitats for microbial life. 79. Mars has a thin exosphere. Above its atmosphere, Mars has an extremely thin layer of particles escaping into space. This exosphere is where atmospheric gases are slowly lost to the solar wind. Measuring this loss helps explain why Mars' atmosphere became so thin over time. 80. Mars has rocks shaped by ancient wind and water. Rovers have found rounded pebbles and layered rocks that could only form in flowing rivers. Other formations look like wind-sculpted dunes hardened into stone. These features show that Mars has been shaped by multiple natural forces throughout its history. 81. Mars has one of the largest dust storms in the solar system. Dust storms on Mars can cover the entire planet and last for weeks. These storms reduce sunlight, making solar-powered missions struggle to generate energy. Scientists study them to understand atmospheric circulation and climate dynamics on Mars. The largest storms may influence long-term temperature changes. 82. Mars' atmosphere is too thin for liquid water to remain stable. Even if ice melts, the low atmospheric pressure causes water to boil away quickly. This makes liquid water nearly impossible to exist on the surface for long. Instead, scientists search for subsurface water, which is more stable. This fact explains why Mars looks so dry and desert-like. 83. Mars has many canyons, including the massive Valles Marineris. Valles Marineris stretches over 4,000 kilometers, making it one of the largest canyon systems in the solar system. It is much deeper and longer than the Grand Canyon on Earth. Scientists believe it formed due to tectonic activity and crust stretching. Its scale shows how dynamic Mars' geology has been. 84. Mars has high concentrations of perchlorates in its soil. Perchlorates are chemical compounds that can be toxic to humans but useful for producing oxygen. They complicate the possibility of farming on Mars without treatment. At the same time, perchlorates could support fuel production for rockets. This dual nature makes them both a challenge and a resource. 85. Mars' atmosphere contains traces of methane. Methane is important because it may come from biological or geological sources. On Earth, most methane is produced by living organisms. Its detection on Mars has raised the possibility of microbial life underground. Scientists continue monitoring seasonal methane changes for clues. 86. The Phoenix lander confirmed water ice on Mars. In 2008, Phoenix dug into the Martian soil and discovered frozen water. This was the first direct evidence of water ice near the surface. The discovery confirmed long-standing theories about Mars' frozen reservoirs. It also raised hope for future human use of this resource. 87. Mars may have subsurface lakes beneath its polar ice. Radar studies suggest that liquid water might exist below the south polar cap. The pressure from ice layers above could keep it liquid. If confirmed, these lakes might be habitats for microbial life. This discovery remains one of the most exciting possibilities in Mars research. 88. Mars has auroras, but they differ from Earth's. Auroras on Mars are caused by solar wind interacting with localized magnetic fields. Unlike Earth's global auroras near the poles, Martian auroras appear in scattered regions. They are not visible to the naked eye but can be detected with instruments. This phenomenon reveals Mars' complex magnetism. 89. Mars has spiders formed by carbon dioxide gas. In the spring, CO2 trapped beneath ice escapes explosively, carving dark channels. These strange shapes look like spider webs from above. They occur mostly near the south polar regions. This is a unique Martian seasonal phenomenon with no direct Earth equivalent. 90. Mars' atmosphere creates beautiful sunsets. Sunsets on Mars appear blue instead of red. This happens because fine dust scatters sunlight differently than on Earth. Blue light penetrates the atmosphere more directly, while red light is scattered away. The result is an alien but stunning evening sky. 91. Mars has tectonic faults but no active plate tectonics. Unlike Earth, Mars does not have moving tectonic plates. Instead, its crust has large fractures and faults from cooling and shrinking. These faults sometimes cause quakes, known as Mars quakes. Studying them helps scientists learn about the planet's interior. 92. Mars' thin atmosphere means sound travels differently. NASA's Perseverance rover recorded sounds on Mars for the first time. They discovered that high-pitched sounds travel slower than low-pitched ones. This means voices or music would sound strange on Mars. It highlights how different daily life would be compared to Earth. 93. Mars has many extinct volcanoes. While Olympus Mons is the largest, smaller volcanoes are scattered across the planet. These volcanic features indicate a once very active geology. Today, Mars appears volcanically dormant, but its past eruptions shaped much of the surface. This gives clues about the planet's internal heat history. 94. Mars has a thin exosphere instead of a dense outer atmosphere. The exosphere is the outermost layer, where gases slowly escape into space. Mars' weak gravity cannot hold these gases well. This explains why Mars lost much of its early atmosphere. The process continues even today. 95. Dust devils frequently occur on Mars. These small whirlwinds of dust can grow kilometers high. NASA rovers have even photographed and recorded them. Surprisingly, some dust devils clean the solar panels of rovers, extending their missions. They show how active Mars' surface still is. 96. Mars has a unique mineral called Martian blueberries. These are small, round hematite-rich stones discovered by Opportunity rover. They formed in ancient wet conditions, proving water once existed. Their presence supported the theory of long-lasting liquid water. They remain one of the most famous Martian discoveries. 97. Mars has massive landslides in its canyons. In Valles Marineris, entire cliffs have collapsed in huge landslides. These events move billions of tons of rock at once. Landslides reveal the geological instability of Mars' crust. They also shape the canyon landscape over millions of years. 98. Mars has ghost dunes. These are ancient sand dunes preserved as hardened impressions in rock. They indicate where winds once shaped the Martian surface. By studying them, scientists can reconstruct past wind directions and climates. Ghost dunes are natural records of Mars' atmospheric history. 99. Mars may have experienced giant floods. Evidence shows huge channels carved by rushing water. These floods likely happened when underground ice melted suddenly. Such events shaped valleys and plains across Mars. They prove water once played a dramatic role in shaping the planet. 100. Mars remains the most explored planet after Earth. Dozens of missions from NASA, ESA, and other agencies have studied Mars. Landers, rovers, and orbiters have provided more data about Mars than any other planet. Despite this, many mysteries remain unsolved. Mars continues to inspire exploration and dreams of human colonization.